All right, in this lesson, we're going to identify the correlation coefficient with the use of a graphing calculator. So in the previous section, we described the independent and dependent variable. We described what the direction was, the strength, is it linear, not linear. So what we're going to be focusing on in this lesson is called Pearson's product moment correlation coefficient, R. Pretty long. So there is a formula here in the blue box that goes through and identifies how you could find this by hand. In our course of IB, they don't require us to use that formula by hand. So what we use instead is the graphing calculator. So on a second video, I will show you how to use the graphing calculator to find this R value. So just to kind of give you a little background on this Pearson's formula, you're taking the average or the mean. So this describes the mean, the average of the x values, and the average of the y values. And then this is your summation notation, and you're finding the difference between each of those r value or those x values to the mean. All right, so here are some of the properties of Pearson's product moment correlation coefficient. So earlier we described that the R value can range anywhere from -1 to 1. The sign of that R value indicates the direction. So a positive value for R indicates the variables are both positively correlated. An increase in one variable results in the increase in the other. So if the x value goes up, the y value goes up. The next property is a negative value for R indicates the variables are negatively correlated. An increase in one variable results in a decrease in the other. If the R value is 0, that means there's no correlation between the two variables. The size of the R indicates the strength. A value of R close to +1 or -1 indicates strong correlation between the two variables. A value of R close to 0 indicates weak correlation between the two variables. So here are some examples of positive correlation on the left and negative correlation on the right. So notice this first example when the R value is equal to 1. We call that perfect positive correlation. And then you'll go down the line on the left side. If your R value is between 0.95 and less than 1, we describe it as very positive. If it's 0.87 to 0.95, we call it strong positive. If it's 0.7 to 0.87, and you can continue down looking at that. Same thing happens on this right side. If our R value is -1, we describe it as perfect negative. If it's -1, greater than -1 and less than -0.95, very strong. You can continue looking down that chart. So here's an example. The Department of Road Safety wants to know if there is an association between the average speed in the metropolitan area and the age of drivers. They commission a device to be fitted in the cars of drivers of different ages. The results are shown in the scatter diagram. And the R value is a positive 0.027. So you're seeing the age of the driver on the x-axis, your independent variable, and then the average speed, kilometers per hour, on the y-axis, the dependent variable. So if we look at this dot right there, the speed at which that driver was going is about 34 kilometers per hour, and their age is 20 years old. The R value is a positive 0.027. So if you look back up to our chart, positive 0.027 falls in this category right here. So how we describe it is very weak positive correlation. So since that R value is in that last category, it's a very weak positive correlation between the two variables. This next example is botanical gardens have been trying a new chemical to control the number of beetles infesting their plants. The result of one of their tests are shown in the table. So this is going to be the x-axis. This will be your y-axis, and you would plot out these ordered pairs. So quantity of chemical in grams, 2 grams, the number of surviving beetles, 11. The next one, quantity of chemicals, 5 grams, and the number of surviving beetles. And you would graph that out on your x and y axes. We're going to show you on the next video how to graph this with the graphing calculator. So part A says draw a scatter diagram. Then part B is determine the correlation coefficient R value, and then describe it. So I'm going to go down to the next slide where the work has been done for us on a graphing calculator. So this is the x-axis, the y-axis, and there's your scatter diagram or scatter plot. What you enter into your calculator is your list 1 and your list 2, and then it'll graph out that graph. What we're going to be looking at on the viewing screen is this number right here. That R value is negative 0.858. So if we go back up to our chart, it's going to change colors here. There's a lot of blue going on. Negative 0.85 is going to fall in this category here. Moderate negative correlation. So to finish up, since that R value is in that category, it is a moderate negative correlation between the quantity of chemicals used and the number of surviving beetles. In general, the more chemicals that are used, the fewer beetles that survive.